So R is the region bounded by this x to the fourth minus 2.3x cubed plus 4, and the horizontal line y equals 4, as shown in the figure. In this case, it's to the right. It'd be above on the real problem, but this is copied from the source guidelines. All right, find the volume of the solid when R is rotated about the horizontal line y equals -2. So y equals -2 is somewhere down here. What method would we use to find the volume?
Washer.
Washer, right? Remember, you start at your axis of revolution, go to the farthest away boundary, and that's your big R. Ignore that it's called R. And then you start at the axis, and you go to your nearer boundary, and that's little r, right? Top minus bottom. So you would have, so your volume would be, what is this, y equals 4? Okay. So you'd have 4 minus -2 squared minus f of x minus -2 squared all times pi. Yes?
Do you ever get in trouble if you're doing notation things that like corresponded with like things in the problem? So like if we would do, if you put in saying like big R minus little r, but there was already the r in the equation, would they, like,
Well, they're going to look for your actual integral setup. They don't care. Like if you write something on the side, like big R and little r, which is actually very common notation. I wish they wouldn't call it region R. Although it is, to be fair to them, it's really common in Calc 3 to call a region R. So I would want to, I understand why they do it, because R for region, right? However, R for radius, so it's kind of annoying. In your integral setup, I wouldn't use R's. I would use the actual notation, like, you know, so 4 minus -2 squared, or you could have just 6, right? And then f of x minus -2 squared. Just to make sure that it's all good. All right. So for this first one, did you all figure out that we're going from 0 to 2.3? You can actually find that the point of intersection on your calculator. This one actually was a really easy equation to solve by hand. So if you didn't find it on your calculator, you can solve by hand really fast. And either way, you get 2.3. All right, so pi integral 0 to 2.3, 4 minus -2 squared minus f of x minus -2 squared dx. 2 points for the integrand, 1 point for the limits, 1 point for the answer, right? So 98.867 or 98.868. They always show you if there's more than one answer they'll accept. They'll show you both. So good. Okay, and you left yours in terms of pi, which is okay. You just got to make sure that multiplies to be correct to 3 decimals. So if you have, let's see. All right, so 31.47 pi, 98.86. So the problem is your 31.470 pi is equal to 98.865 or 98.866. You did not, you don't have enough decimals for it to be, the final answer to be correct to 3. So you need to make sure, so I wouldn't even do it with a pi. I would just put it all in and give me a final answer. They'll accept that if it's correct, but it's got to be equivalent to the final answer up to 3 decimals. Okay. All right. So good, 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 good. 100%. Good. Everybody got it. Beautiful. Yeah. I like your setups. I don't see any missing dx's. Good. Fantastic. Well done. All right. So, letter B. All right, region R is the base of a solid. Each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg on the base. We're having a lot of isosceles right triangles with legs on the base. Yeah. I know. All right. So that means that this distance is this distance, perpendicular to the x-axis, right? So your leg length is top minus bottom, so just 4 minus f. what's your volume then? So when you do volume by cross section, it's just the integral of the area of the cross section. So it's the integral of the area of this triangle, which is 1/2 times this, or 1/2 times this squared, right? Okay, so you end up with 1/2 times 4 minus f of x squared to get the area of that triangle, 3.574-ish. So you got it. Well done. Good setup. Yes. Yes. Yeah, and you can just call FF. You don't have to write out the whole function. But yes, that's perfect. Okay. Again, same thing. But yeah, beautiful. You get full credit. So. Yep. Okay, good. Okay, you guys would get 0. Oh, wait, is that your setup over there?
Works over there, yeah.
Okay, make sure you link the work to the answer, right? Okay, but yeah, then it's fine. All right, well done. Everyone looks great, right? If they give you a function name, make your life easy and just use it, right? So you don't have to write out the whole function every time. All right, and once again, we've done this now like 3 or 4 times. Vertical line x equals k divides region R into 2 regions with equal areas, right? But do not solve an equation involving an integral whose solution would give the value of k. There are multiple ways to do this. I'm just going to walk around from board to board and see what we've got. So this one says 2 integral 0 to k. So 2 times the area from 0 to k equals the whole area. So that's correct. Very good. Integral 0 to k equals the integral from k to 2.3. Lovely. Half the whole area equals the integral from 0 to k. Very nice. Half the whole area equals very nice. Same thing. Wow, we have a repeat. Okay. All right. Good. Same thing again. Very nice. Integral 0 to k equals half the area again. Lovely. 2 times the integral from 0 to k equals the whole area. Perfect. You guys all right. So they're all perfect, right? Well done. There are multiple ways to do that, and every single one of the ways you've got on the board are correct. So good job. Okay. So these are actually Miss Grunwald's slides. So I want, she was generous enough to share them with me so that you guys can see what her students are seeing, so that we're all kind of on the same page as far as your test tomorrow. Your test is on chapter 6, in case you didn't know. It's all calculator, 100%. There are only 4 questions in the essential learning part, and yet it's more than half your score, right? So, yeah. So the retakeable part, more than half of the points on the test are in the retakeable part. Even though it's only 4 questions, one of them has multiple parts. It's one of those like A, B, C, D, E kind of a thing. So it's really more like 10 questions, right? It's just numbered 1 through 4, but one has a whole bunch of parts. Okay. All right. So anyway, so that's your essential part. Then there are 2. Okay. Then there are 2 short multiple choice questions, just 2 points each. And then 2 free response. The free response questions are actual AP problems. So they are multiple parts, right? They're 2 questions with multiple parts, but the one that you just did was an AP problem, right? So they're probably going to be fairly similar to like the ones that you just did. 21 points. That's because one of the questions, we actually added a few extra parts to it. So we took an AP problem and enhanced it, right? So it's AP enhanced.
Is that because you thought it was too easy before?
No, we didn't make it any harder. We just added more stuff. We just wanted to make sure we covered everything. So, okay, so topics on your test: area, average value, disc, washer, shell, cross section, and arc length. That's your whole test. Yes.
Will we be specifically asked to like show method for the question?
No one will ask you any method. Like you will not. There is not one problem on this test that says the words disc, washer, or shell. It'll be your choice every time. However, there is at least one problem where if you don't know shell, you won't be able to do it. So that is a challenge. It's really not. Just learn shell, right? Okay. All right. So yeah, make sure you know shell because there is at least one. There are several problems that can be done with shell, and I think there's one that you could do with washer sideways dy, but it's not easy, but it could be done. And then there is one where it could be done, but it's really hard to turn it sideways and do it dy. So but it's real easy to do a shell, right? Shell is usually easy. So if you encounter a vertical axis of rotation, my personal suggestion would be go for shell. Okay.
So will there be any divide the region like the last question we just did?
Like the last question we just did? That's a fair question. So did you guys hear that? Where Gavin just asked? He said, will there be any problems where it's like the whole K thing where you have to split the region into two regions? Yeah, that's certainly fair game. Everything we've done in class is fair game to show on the test. Not on this test, no. Most of the time on the AP exam, you're also not asked to solve. There have been times when you've been asked to solve, but not on this test. I will tell you, if you're ever asked to solve, it's usually with an easy function. Like where your area ends up being something really simple, like you have the integral from 0 to k of 4 minus x squared, right, equals, whatever it equals, and then you just anti-differentiate and plug in the k minus plug in the 0 and solve the equation. So, anyway, but not on this test. All right, yes, Keith.
You mentioned that in the past, sometimes the AP test would try and force kids to turn into dy. Will you be subjecting us to this one?
Will I be exposing you to a challenging curriculum? Is that what you're saying? I will tell you, in my humble opinion, the test is way too easy. That's my answer to that question. Okay? All right. So, yes.
Do you take the AP test?
So, all right, I'm going to pause. I'm not saying that there's going to be linear motion on your test, but there might be parts in here that might show up on your test. So we're doing this one as a review of a couple of different little topics that might pop up, right? Okay, so Johanna jogs along a straight path. From time 0 to 40, her velocity is given by a differentiable function v. Selected values of v, where t is measured in minutes and v is in meters per minute, are given in the table above. Part A, use the data to estimate the value of v prime of 16. Part B, using correct units, explain the meaning of the integral from 0 to 40 of the absolute value of v of t dt in the context of the problem. Then approximate that using a right-Riemann sum with 4 subintervals indicated by the data in the table. Part C, Bob is riding his bike along the same path. For time 0 to 10, his velocity is measured by b of t, b for Bob, where t is measured in minutes and v is in meters per minute. Find Bob's acceleration at t equals 5. Based on the model B from part C, find Bob's average velocity over the time interval from 0 to 10. So there are several things in this problem that might pop up, so it's a good one to practice with. I am going to give you the option. If you would like to put this on your whiteboards, that's fine. If you would like to work in your desks on paper, that's fine. If you want to stay in your desks and work on portable whiteboards, that's fine. Whatever you prefer. Yes, Ryan? Oh, good question. This, you don't see it, but it's actually a no calculator question. So no calculators for this question. I'm going to give you about 10 minutes starting now. Freeze so that our board matches. There we go. So v prime of 16, when you're doing a derivative from a table, you just go up one, down one, and do slope of the secant. So we would have 240, 240 minus 200 over 20 minus 12. If you clean this up, you get 40 over 8 over 5. It didn't ask for units, but let's just pretend it asked for units, right? So if it happened to ask for units, what would the units be for V prime? Meters per minute squared. Why? Because the top is in meters per minute and the bottom is in minutes, so it's meters per minute divided by minutes, right? Meters per minute or meters per minute squared. All right, part B. Using correct units, explain the meaning of the integral 0 to 40 of the absolute value of v of t in the context of the problem. Does anyone remember what the definite integral of the absolute value of the velocity gives you? Total distance traveled, right? So what does this mean? So this right here, you would say, like you could actually write, this gives the total distance traveled by Johanna in meters from t equals 0 to t equals 40 minutes, right? So make sure you have input and output. 0 minutes to 40 minutes is gorgeous, represents total distance in meters. This is absolute perfection, right? So well done, beautifully written. Let's see. Yeah, and it looks like just about all of you got it. So total distance in meters, and yeah, good. Yeah, is the total. Look at you guys. Oh, fantastic. Oops. Okay, so this board, you got total distance traveled in meters. What'd you forget? Time. Yep. Okay. Oh, that board, you're missing. What are you missing? Units for both the input and the output, right? So make sure you got units there. Distance traveled. I like the little in meters stuck in there. That's good. All right, you got it. In meters. Oops. You guys had a mistake. What's your mistake? You did 4 instead of 40, right? Okay. Good. Overall, very good. Okay. Part C. Oh, to actually find it, write Riemann sum. So let's do our right Riemann sum. So this approximately equal to. All right. So we're doing the definite integral of the absolute value of the velocity. Are the widths equal? So what's the first width? 12. I'm going to draw the rectangles up here so you can see. Rectangle, 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 rectangle. So first rectangle goes from 0 to 12. Right Riemann sum. What's the first height? 200. What's the next width? 8. What's the next height? 240. What's the next width? 4. What's the next height? Not negative 220? No, because it's absolute value. Last width? 16. Last height, 150. Okay. And if you don't want to know what that equals, I will tell you 7,600 meters, right? But you didn't have a calculator. Could you just leave it unsimplified?
Yep.
Absolutely, as long as it's numeric. Yes, you can leave it unsimplified. All right, Bob is riding his bicycle. I don't know if I've ever taught a student named Bob. I love that name. It's fun to say, right?
I've never heard.
Yeah.
I have one.
Anyway, okay. So here we go. How do I find, if that's a velocity function, what would be the acceleration function? The derivative, right? So b prime. So b prime of t would be 3t squared minus 12t. We want b prime of 5. So you're just plugging in a 5. So 75 minus 60, 15. And they didn't even ask for units. If they asked for units, what would the units be? Meters per minute squared. It's acceleration. Okay. All right. Average velocity. Well, average velocity is change in position over change in time. But instead of sitting there and doing our average rate of change by doing on the position, I'm going to use the average value theorem just for fun, right? So I'm going to do b sub ab, right, from 0 to 10. So I get 1 over 10 minus 0 integral 0 to 10 of, I want the average of the velocity. This is my velocity function, right? You put whatever you want the average of right here. So it would be, I'm going to write it out because I'm going to have to anti-differentiate by hand, plus 300 dt. So you get 1/10 times 1/4 t to the 4th minus 2t cubed plus 300t from 0 to 10, and plugging in 1/10 times, so you get 1 with 4 zeros over 4 minus 2 with 3 zeros plus 3 zeros. And then if you plug in the 0, it all just goes to 0, right? So you've got that. So then you can kill off a 10. Kabam, goodbye, 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 goodbye. And 1,000 over 4 is 250. So you have 250 minus 200 plus 300, which is equal to 350. And this is in meters per minute. They didn't ask for units, so you shouldn't give units, but I might ask you for units, so it's good to know. All right, any questions on average value formula? Finding an average value, 1 over b minus a times the integral from a to b of whatever you want the average of. Right? Good. All right. Next. Oh, I got to close this and go into another document. Escape. Okay. So, minimize. And here's the other one. Okay. Last problem of the day. Oh, you know what? Before we get to the last problem of the day, I got to mention something. So, if you have not finished quiz 6-1, you are not to work on the last problem. You are to finish quiz 6-1. So, unless you haven't started it yet, we're a couple people have been out a lot. But those of you who have started it and just need to finish it up, please get that done. So I'm missing quiz 6-1. It looks like from 2 groups. So Blake, your group is missing quiz 6-1. Let's see. Blake, Cooper. Okay. Jennifer and Faith have been out. Luke's in that group. Okay. So, tweet Ian and Vishali, do what you can. Vishali, you've been out. It's okay if you don't finish, right? Okay. And then, yeah, that whole group. So, Anthony. Yeah, that's it. Just that one group. Well, 2 groups, but, okay. All right. And then the other thing I want to mention before, am I still recording? Oh, that's okay. Where's my internet? Let's see. That's all right. Okay, so here, I'm going to pause. Ask right now. So I'm going to do something else instead. So I am going to change this. And I'm going to change this. Because squares are too easy. All right, so, okay. So we have this lovely figure. That's y equals 6. This is y equals 4 ln 3 minus x. It's a calculator question. This is x equals 2. Find the area you can do in your sleep. Find the volume revolved about y equals 8. You should be able to do without a problem. Each cross-section perpendicular to the x-axis is a, name a shape of your choice that you would like to pick.
Square.
Rectangle with the height of the
Hexagon.
Square.
You guys want a square? All right. Okay.
Yes.
Wait, do something that just do what's ever going to be on our test.
I'm not telling you what's on your test.
We
I
do
will
like-
tell you it's a geographical shape.
Can we do a triangle with the hypotenuse as the...
Do you guys want to do
No.
an isosceles triangle with the hypotenuse on the base? Equilateral triangle?
Yeah. Do it on hypotenuse.
Hypotenuse, you want isosceles?
Yeah.
All right. Okay. Okay, so we're going to do Each cross section perpendicular to the x-axis is an isosceles right triangle where the hypotenuse is on the base. All right, so isosceles right triangle, hypotenuse on the base. All right, for part E, just for the heck of it, I want you to find the arc length of this of the y equals 4 ln 3 minus x over the interval from 0 to 2. All right, 5 parts. So you've got 5 parts to do. Take about 10-ish minutes or so. See what you can do with this. So part 1 or part A, area of R. It's just the integral of top minus bottom. Right, let me make this big. Okay, so part A, 6.816 or 6.817. Good, good. Oops. Okay, so this group in the back, who's the point for part A? Why?
DX.
Missing a DX. Don't lose a point for missing a DX tomorrow, right? All right, because one point, your test, the total point for the test is only 53. You lose 1 point for a DX, that's 2% of your grade. Yeah. So 2% of your grade for one missing DX. If you miss DXs 10 times, that's 20% of your grade gone from DXs. Okay? Now it makes it seem important, doesn't it? Okay. All right. Part B. Find the volume of the solid generator when we revolve about y equals 8. What method do you have to use?
Washer.
Washer. So it would be big R 8 minus the log function squared, and then little r would be 8 minus 6 squared, right? So you end up with pi, don't forget the pi, 0 to 2, 8 minus log squared minus 8 minus 6 squared, 168.179. Good, 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 good. Are you guys not? Oh, is that the same problem? Yeah, something happened. Everything, your setup is perfect. You're missing a parenthesis, but that's okay. But your answer, did you forget the pi? Yeah. Yep. Yeah, if you multiply that by 3, it's roughly 150 something, so that's probably what it is. Yeah, you're probably missing a pi. Okay. All right. Okay. Cool. Good, good, good. Wonderful. All right, well done. All right, the next one we modified to be cross sections that are isosceles right triangles with the hypotenuse on the base. So your base is 6 minus the log function, right? When you turn an isosceles right triangle on its side like this, the height is actually half the base. So what you end up with for your volume is 1/2 times the base, which is 6 minus the log function, times the height, which is half of 6 minus the log function. So you end up with 1/4 times your 6 minus your log function squared, which, however you get it. Some of you guys like to do this and divide it by root 2, divide by root 2, and either way you're going to end up with 1/4. No matter how you do it, you're going to end up with 1/4. So times 6 minus log function squared. So 6.5666. Okay, you guys left it blank. The 1/4 is right, but you should have a square root around here. Do that square. Okay. All right. Good. Yeah. Well done. Well done. Look at this. We're 3 for 3. We've got 4 correct answers. Oops. I was going to say, this is perfect. Your setup is perfect.
I think it's just a calculator.
Yeah. Yeah. So be careful. All right. The arc length is missing the A. It's an arc length. Okay. So arc length, in case you've forgotten formula for arc length. So arc length is the integral of the square root of 1 plus f prime. Oh, I skipped D. I'm so sorry. Oh, I'm sorry. Here, let me erase. Okay. We're revolving about the line x equals -2. What method should you use? Shell, right? So when you're doing shell, you have 2 pi r. So our radius, this is our axis, right? So our radius would be, think of an x as just being somewhere in here, right minus left, x minus -2, or x plus 2. And then height is just top minus bottom, so it's going to be 6 minus the log function, which I wish they had named f of x, but nothing we can do about that. So, yeah.
You guys like,
You could write let f of x equal, yeah, and then you can use f of x. Oh, and there's the. Okay, just so you know, arc length, integral square root 1 plus f prime squared, right? Integral square root 1 plus f prime squared. Okay, have a wonderful afternoon, and